Hi all. Today we are going to discuss about the case study in the B tree. So we already discussed how the B tree can be used in the real world entity and as well as how we can use it in the database management system, because it plays a major role. Wherever we are going to store certain data. Based on storing of the data, we can able to retrieve the data. So how we can easily retrieve the data? Only with the help of indexing, we can able to retrieve the data. For indexing alone, we can go for the B tree. So if I want to store that data or store the information in my B tree, definitely it will have the certain photos. Also, we can able to retrieve the data. So in that thing, today we are going to discuss the case study for this particular graph. Particular tree. This tree can have the order of F5. Order is 5. For this particular order, we go into how the data can be removed. That is a 64, 23, 72, 65. This data are not available over here. We are going to remove this thing, or we are going to delete that particular data in this particular graph. How it can be possible. For that, we are going to consider the two cases. First case is we have to identify the target. Our target node, either it can be a leaf node or it can be an internal node. If my target node is a leaf node, we have to check the binary, that is a balanced binary tree or not. For that, we are going to check all the nodes except the root node. It will maintain the minimum number of keys. So for here, considering m equal to 5 means the minimum. The children is m by 2, so 5 by 2, it is a 2.5. We are going to round up into 3. And also we are having the key, that is the m minus 1. So here we have to, here it is a maximum key is the this one. So this is the minimum. So the minimum children required is a 2. That is a m by 2 minus 1. So 3 minus 1 is a 2. So that children, this is key, this is a children. So minimum it will have a 4 children. So this only we are going to consider. So first we have to consider this table. For that we are going to consider these two cases. First we will take the target node is a leaf node. So if my target node is a leaf node, definitely it will check it is a whether it will have more than the minimum number of key or it will have the minimum number of the key. If it is a more number of the minimum number of key, directly we can able to remove it. We doesn't go to check any other thing. So in these, it can contain only the minimum number of key. We have to borrow the thing, borrow the data from either right side of the siblings or the left side of the siblings. If both the thing is not possible, we are going to merge the data. So if it is not possible, these two cases not possible, we are going to merge the thing. Shall we do?
Yes, ma'am.
Okay, first, who is going to delete the 64 from the table, from this tree?
64, now we deleting the value 64. 64 is between the 50 and 80. Then it comes to 60 and 70. Then there are 3 nodes in between the 4. That is 64 and 65, 68. Then now we deleting the value 64.
Value of 64. So we can directly delete this one. Because it is in the leaf node, it will satisfy the condition. So we can remove the 3. What is the next value we are going to delete? 23. Who is going to delete the 23?
Good afternoon. Actually, the 23 lies as the left side of this 50 and also to the right side of 20. Actually, the value is more than 20, so the value is in the right of 20. Actually, if we want to delete this 23, we should apply this rule. Actually, the node contains minimum number of keys. See, 23 this node, that is 23, 27 has minimum number of nodes. So, if we want to delete this, then we should borrow something from left side or right side of the tree, of the node actually. So, here we can see that in this node there are 3 elements. So, we can easily take the last element, that is maximum element, and can then be displaced into this position. According to that, we can actually delete this node. And if we take 16, then we should displace 20 to this area and take 16 to the parent node. So, if we take 20 will come here and 16 will be displaced there.
Very good. The next 72. For that we are going to check the another condition. So where the 72 is available?
So 72 is located in between 50 and 80. Then it comes to 70 and 72. In between 72 is located. Here we are checking for that immediate left subtree. But here we are having the minimum number of key, that is 2. Then we are looking for the right subtree. Here we are having the minimum number of key, but more than minimum number of key, we are having the 3 nodes. So we are replacing this 77 because it is the minimum value in the right subtree to this place. Then this 75 will come to this place. Now, here it becomes 78 and 79. Here the 77 will be replaced. Then here we will remove this 72 because that is the element we need to be eliminated in this node. Here the 73 is as it is here. The 75 will come.
Okay, very good. The next we are going to remove the value 65. So how we can remove the value of 65 means here we are checking the condition. This both the condition is false. How I am saying this thing means we are checking the left subtree as well as the right subtree. In both the cases, it will have only the minimum number of key. If I remove any one of the key, it does not satisfy the binary tree. So we have to check the third condition, that is the merging with the parents. So how we can merge? That will be explained later. Here merging, either we can merge with the left side or we can merge with the right side.
So here we are going to merge with the left side. So here it will come. And 65 will be deleted.
Just we are going to merge these two things. So how we are merging means one with the help of the parent node only we can able to merge. Parent node will be joined over here. Through that we can able to merge with this particular. So the next node is we are going to delete the value of, I think this everything is completed. Now we are going to delete the value of 20. So 20 where it would be available? It is less than 50, so it will check over here. Here also it is greater than 20, automatically it will be coming over here. So this node we are going to delete the thing.
actually here we need to take right subtree or left subtree. Here there is no right subtree, right? So we can take left subtree and looking at this, it has minimum number of keys at 2, the value is 2. So we merge parent value with these two nodes and it will become like, already there was given 4, 5, 6, 14, 15, 16, 20 and 27. Now we need to delete 20, right? So we need to cancel this 20. The balance keys in this are 4. Now it will become 27. Now look at this parent node. There is one value in the node. So for binary tree there should be 2 values. So take the right subtree of this node and the parent of this node and match the values. If we compare these two, 10, 70 and 77 will be there. And here it has the minimum value of 2. So merge these two values with the parent node. Taking 50 because it is the minimum value and it will become 77. Now apply these here.
restructure and also we can able to retrieve the data. This is one of the major cases why nowadays industries are going for this one, because it will have an index. Through that particular index we can able to easily access the